All right, so what do we got here? We've got a last minute addition to the twin. I think there's another one too. It's got to be redone, maybe. We got to change another one too, I got to look at. Anyways, I added this one in 24. You're supposed to evaluate things using either your brain that God gave you or using some common sense. So here's the similar example. And if I interpret this, this is asking me what power of root 5 is 625. You know, I know that 625 is 5 to the fourth. That's what I know. Okay. And I know if you take a root of 5 and you square it, you get 5. That's what I know. So because of that, it would take 4 sets of a root 5 squared to be 625. What I did is I identified a base kind of that was common. And, just to prove to you that I'm right, because some days I'm wrong, root 5 raised to the 8th, 625. So the answer is 8. Now, if you can't do that, you can use change base. I'm going to use the ln because that's what I like. Natural log is 625 over natural log root 5. I know some kids that have a hard time pushing that in a calculator. They really just type it in. But, some kids don't push buttons very well. And surprise, it's still 8. Preferably you do it the way I did with that brain that God gave you. That's what I would hope. It seems like there was another one that I changed. This isn't the piece of paper I want. So let me glance real quick while I'm still recording. Maybe I didn't. I might be thinking about something else. I do know that I need to go ahead and add something in. So I'm going to add something in real quick. I'm going to pause this video and I'll be right back. Because there's another one you need. And I just remembered I need to put it in. So be right back. All right, so I'm back. I had to make up another 25. This will be the last thing I add to this thing. So here is a 25. You're supposed to solve a logarithm. There's more than one logarithm in here. So I'm going to do the similar example. And what we're going to do is we're going to get our logarithms on one side. That way we can do what's called a condensing. If I move that negative logarithm to the left, it will become a positive logarithm. The 2 is going to stay on the right. Now, you should be familiar with this property. If you have the product of two things, you can break them apart through addition. Seems like most of my kids were when I taught that. So hopefully you still are. Let me move this little thing out of the way. All right. So I'm going to read this rule from right to left. I'm going to go the other way around. It says I can create a single log of base 3, and inside is the product of x minus 9 and x minus 3, still equal to 2. Now here's a base. Here's the answer of the logarithm, the argument of the logarithm, and that leaves e. So 3 to the second must be equal to x minus 9 times x minus 3. And I believe if you saw that line right there, you do the double distributive property. You get an x squared minus a 3x minus a 9x, so minus a 12x, and then plus a 27. Now you'd set it equal to 0 and you'd try to factor it. If we do 27 minus 9, we get an 18. And are there factors of 18 that add to 12? There aren't, are there? Well, this one's kind of ugly. I thought this thing would work nice. I don't think I made any mistakes. Minus 12x plus 27. 27 minus 9 is 18. That or I'm just really tired. There are no factors of 18 that add 12. You got a 3 and a 6, that's a 9. 1 and 18, that's a 19 or 17. 2 and a 9 is an 11. So we get to do the quadratic formula. Opposite b would be a 12 plus or minus square root of a 12 squared minus 4 times a, which is 1, times c, which is 18. Sitting pretty over twice a 1. So what's in that radical? You got a 12 squared minus a 4 times a 1 times an 18, a 72. These are ugly answers. Bummer. Root 72, last I checked, was 36 times 2. So 12 plus or minus 6 root 2. Both pieces over 2. 6 plus or minus 3 root 2. Now, these need to be checked to see if they actually work. All right? The deal is on a logarithm, you can't have an argument less than 0. So 6 minus 3 root 2 is that decimal right there. And if I threw it right here, I would have a negative entry. Wouldn't I? That would become negative. Because if I take away 3, bam, negative number. So 6 minus 3 root 2 is extraneous. Now let's see what 6 plus 3 root 2 is. It's 10.24. If I take away 3, I'm going to be positive. If I take away 9, I'm going to be positive. So 6 plus 3 root 2 is real. And there is number 25. So that does it for the twin. All I gotta do now is get it stopped.